Herzlich willkommen zum zweiten Hop User Meetup, live aus dem Filmstudio der it-novum. Guten Morgen zusammen. Mein Name ist Stefan Müller. An meiner Seite ist der Philipp Heck und wir freuen uns wirklich, dass Sie heute hier so zahlreich erschienen sind und uns bei dem Meetup hier Gesellschaft leisten und wir eine spannende Veranstaltung haben werden. Ja, das Thema smartes Datenmanagement, Data Warehousing, Data Lakes sind aktueller denn je. Egal, ob Sie, wie gesagt, ein Data Warehouse mit Daten befüllen wollen, ein Data Lake mit Daten beladen möchten oder eine Machine Learning oder KI-Applikation betreiben möchten. Sie müssen Ihre Data Pipelines im Griff haben. Und ein wunderbares Werkzeug aus der Open-Source-Welt, um genau diese Herausforderungen zu bewerkstelligen und zu meistern, ist Apache Hop. Wir würden gerne ein bisschen besser verstehen, wer heute hier natürlich auch uns Gesellschaft leistet, im Plenum ist und was sie für Anforderungen haben. Und vor diesem Hintergrund mit einer kleinen Umfrage starten. Die ist wirklich ganz kurz. Wir freuen uns, wenn Sie hier zahlreich teilnehmen. Die erste Frage beschäftigt sich damit, suchen Sie eher sowas im Bereich Data Warehousing? Liegen da Ihre Herausforderungen? Oder haben Sie vielleicht dann auch noch andere zusätzliche Anforderungen, vielleicht in Richtung Data Lake, Big Data, Cloud Computing oder vielleicht auch die Befüllung von Machine Learning Algorithmen mit Daten? Und zu guter Letzt, haben Sie schon mal Kontakt zu Apache Hop gehabt? Sind Sie interessiert? Haben Sie das schon im Einsatz? Das würden wir entsprechend gerne ein bisschen besser verstehen. Dann, wie gesagt, nehmen Sie gerne teil. Wir schauen dann auch mal auf die Ergebnisse. Eine Sekunde noch. Also, viele Teilnehmer, die im Bereich Data Warehousing unterwegs sind, dann aber auch durchaus Anforderungen jenseits des Data Warehouse-Umfelds, also quasi in der neuen Datenwelt und vereinzelt schon Erfahrungen auch mit Apache Hop. Was ich jetzt schon versprechen kann, alle werden heute auf ihre Kosten kommen und damit würde ich auch gerne mal einen kurzen Blick auf die Agenda werfen. Also wir haben das Thema aus unterschiedlichen Perspektiven beleuchtend in den Vorträgen. Einmal Architektursichten, die grundsätzlichen Konzepte, auch ein paar Insights bezüglich der Community und dann eben auch Highlights aus den ersten Umsetzungsprojekten. Was gibt es da für Learnings? Was haben wir da mitgenommen? Und zu guter Letzt auch einen eher analytischen Case, wo dann Hop entsprechend mit Neo4j kombiniert wird. Bevor wir dann auch direkt mit dem ersten Vortrag starten, noch ein paar organisatorische Hinweise von meiner Seite. Wir werden die Vorträge entsprechend aufzeichnen und im Nachgang gemeinsam mit den Präsentationen Ihnen auch zur Verfügung stellen. Also dann entsprechend ein Nachgangsmailing von uns der it-novum geben, wo Sie alle Informationen dann auch direkt nochmal zur Verfügung gestellt bekommen. Wenn Sie Fragen haben, machen Sie das bitte gerne. Das Format lebt natürlich auch davon, dass hier Informationen ausgetauscht werden. Klar, virtuell hat man da ein paar Einschränkungen im Vergleich zum persönlichen Meetup, aber wenn Sie Fragen haben, gerne in den Chat stellen. Wir nehmen das alles auf und am Ende einer jeden Session wird es die Möglichkeit geben oder werde ich dann auch die Fragen an die jeweiligen Referenten stellen, sodass diese dann auch beantwortet werden. Ja, so viel zur Einleitung. Dann würde ich sagen, legen wir auch direkt los. Ich freue mich sehr, dass wir ja die beiden führenden Köpfe hinter Apache Hop auch heute hier in der Veranstaltung haben, Bart Maertens. Und genau, jetzt wir werden starten mit ein paar Einblicken zur High-Level-Architektur, zu Hop und auch ein paar Insights zur Community und auch zum Thema, wie ist es eigentlich, ein Apache Hop-Projekt zu sein und ein Apache-Projekt zu sein, was bedeutet das? Matt, Bart, I will switch to English now.
Thank you.
It's great having you here again, and we are really looking forward to your presentation. Matt, yeah, we are especially thankful you are in the US in the middle of the night. So
no, that's
we're
no
very
worries.
grateful that you are joining us. That's really nice and great. And yeah, the stage is yours.
So yeah, thank you very much for the welcome words. Right, it's really no bother. Greetings from hot Austin, Texas. Yeah, so let me just share my screen, and I prepared a small slide deck to talk a little bit about what Apache Hop is and why we did Apache Hop. Why would you use Apache Hop? Some guiding principles that we used in the software, in the project. We'll talk a little bit about the architecture and the roadmap. And Bart later then is going to talk about community in his own slide deck, right? So the tagline, if you go to our website, is facilitates all aspects of data and metadata orchestration, which is pretty much so broad that it's meaningless, right? Well, so typical use cases for Apache Hop are data integration, data orchestration, ETL. These things are usually synonymous a little bit. But data migration, message processing, data synchronization, Internet of Things, big data, these are all, let's say, subjects that are in the purview of Apache Hop. Now, the name is a recursive acronym, the Hop Orchestration Platform. That was a little bit of a tradition, right? But it means that we don't just do data wrangling. We don't just do data parallel pipelines and handle the results of execution in things with workflows. But we also, like the tagline says, do everything around that. Metadata handling, management, editing in the GUI with APIs, handling insights, execution lineage, logging, that sort of stuff, right? And obviously configuration, complexity, handling, lifecycle management, and so on and so on. Yeah, the background, Bart will tell more. We'll speak about the community around this, but we started with an older version of Kettle some years ago. And, you know, Kettle was then something that we kept adding features to, plugins from the community, WebSpoon to run the GUI in a browser, patches. So this whole thing represents about 21 years of software development already. And so we started, you know, changing a lot of stuff, a new GUI, a new metadata backend, simplified tool set, and I will show a little bit about that in a second. But this has been a lot of work, right? Years on end. And so the situation now is the software is owned and copyrighted by the Apache Software Foundation. We have a simple website, hop.apache.org. It's one of the simpler. And the source code is also publicly available under an Apache's license. And we are now at version 2.0. We just released version 2.0, and we're building 2.1 continuously. And again, you know, Bart will talk more about the growing of the community, which is going really well. So I'm not gonna. So I thought just to give you a short real life walkthrough of Apache Hop and you know, guide you to the website for those people, the 70% that haven't used Apache Hop yet. I'll show you where you can find it, where you can download it. And yeah, let's start with that, right? And here we go. So like I said, hop.apache.org is where the good stuff is at. And the interesting part about this website is that, again, it's a community-led initiative. All the, let's say, source code for the website and all the documentation is also part of the project. So it's also part of the source code. In fact, if you go to the user manual, the documentation for, let's say, all the transforms that we're using, let's say Avro, for example. All those things are, let's just get this, are not just available, they are also version, right? So you can see that this is a new transform for version 2.0, and the other versions are grayed out. So this is really useful to make sure that you can always find descriptions and things that are going on. I would also welcome you to use the search bar at the top if you want to find out what the documentation is for a Docker container, stuff like that. This is where you can find it. The downloads is simply on the download link. You can just download the binaries, no need to compile anything. Version 2.0 requires Java 11 to be installed, as mentioned here. Quite confusion, and the other versions are still on Java 8, but just use the latest and the greatest. At that point, you pretty much just need to unzip it. And, let me just make my screen as large as I can. Hop. This is where I unzip this. And for Mac and Linux systems, we have a bunch of shell scripts. And as you can see, we named the shell scripts after the task that they do. So Hop GUI will start the Hop graphical user interface. Hop Conf will allow you to configure your environment, your projects on the system. Hop Search will search. Hop Run will run a workflow or pipeline. The Hop Server will start a server. You get the point, right? And so this is done to make it easier for new people to just get on board. You have a pipeline and you want to run it, you use Hop Run. You can put that in a cron tab or run it manually. Okay, so what most people use in their day-to-day job is Hop GUI. So the Hop GUI is rebuilt from the ground up to be a pluggable and scalable graphical user interface. So this is, I guess, new from Kettle, is that we made great efforts in making everything in this user interface really easily pluggable. So if you would remove plugins like unit testing, which the next speaker will talk about, I guess, right after Bart. So that sort of stuff is all plugins. So if you remove that plugin, the user interface will simplify, certain things will become unavailable. But this speaks to the modularity of the whole thing. What we're seeing is a pipeline. Here is an example of a workflow where task actions, we call them, are executed one after the other, right? So very simple, one after the other. And you can actually zoom in either by clicking on a action and then say open pipeline, or we have shortcuts for that. And then you can see the pipeline, which is a parallel streaming set of transforms, one after the other, which execute things in parallel. I talked about metadata. So what you're seeing now is the data orchestration perspective. But we also have a metadata perspective where you can see all connections to, let's say, a relational database like Postgres, the run configurations for, let's say, data flow. We have a file explorer. We have a search perspective, the plugin explorer, where you can see all the different types of plugins that are loaded. And there's also a Neo4j perspective in which you can see the logging of your transformations and workflows if you want that, right? I don't have it configured right now. I talked a little bit about the ability to I'll talk a little bit about the ability to run with different engines. I kind of hinted at it in the metadata, but I will come back to that in a second. Right. Important to note is that we have the GUI available for 4 platforms. We have it for Linux, Mac, and Windows, but also for web users. So you can run this GUI in a web browser tab, and it will look exactly the same. What's also interesting is that we have this GUI available in both, let's say, light mode and dark mode on all 4 platforms. So this is the dark mode version of that, and yeah, there's a light version as well. Okay. I hope that kind of suffices as a short introduction. And so, but why did we do this? Why do we use a tool like Apache Hop in the first place, right? That's for maybe for the 20-30% of the people that haven't used the data orchestration tool yet. Why would you do that? Well, you know, one of the first and foremost reason is to lower the development time and cost when we talk about data integration or data orchestration solutions. Typically, if you read data from, let's say, a BigQuery or a database or an Oracle or indeed an SAP system, and you want to put this in a data warehouse, we're already, for these 2 systems, we're already talk about lots of things that need to be transformed, cleaned up, enriched. We talk about connecting to various types of technologies. And yeah, that just takes time. And with a data orchestration tool like Hop, we can lower the development time, but also lower the maintenance time afterwards. And so what we also want to do by providing GUI tools and advanced logging and stuff like that is increase the transparency. We want to avoid something that somebody wrote to become like a black box. It needs to be transparent. It needs to be accessible. We also want to improve stability, right? By saying like, this is not something new that was developed. This is code that has been around for 20 years. There's not likely that you will find like really weird things out of the box, right? And we want to make it easier for people to learn stuff. You know, learning a Spark API, for example, is not that easy, right? And with a tool like Hop, it's easier. There's also something like protection against brain drain, or the bus factor we call it, right? What if one of your developers is killed by a bus? That's not how they say it, but yeah, what if the person leaves the company and all of a sudden now you don't have anybody to take over that work? Those are all sorts of reasons why you would use an advanced data orchestration tool. And we are living in a quickly diversifying technological landscape. The idea of one Hadoop system which covers everything in the enterprise hasn't really come to fruition. We've seen like an amalgamation of technologies just pop up all the time, new things. And I think there was a study at one point that says like if you have 2 systems, it's like one connection between them in general, but if you have more and more systems, the complexities increase exponentially almost. And a tool like Apache Hop is an answer to that exploding complexity in the organization. So we want to be constantly innovating to catch up with the latest technologies. And we want to do development independent from a single large corporation. We want to be talking to a lot of large corporations. And we want to do this by and for data orchestration professionals like ourselves. Right? So let's talk a little bit about the architecture. The most important thing that people actually usually don't know about is that Apache Hop is metadata driven. So what that means is that no code is ever generated no code is compiled or packaged or deployed. These things are the purview of what we call code generators in the business. I think tools like SAS, Data Warehouse Builder, Oracle Data Integrator, Talent, Data Stage to a point, they're all like in that category. Hop falls under the category of engine metadata-driven data integration tools like Kettle before, but also Informatica, obviously, right? And so what that means is that metadata means in this context, ETL metadata, and we execute requirements captured in metadata as is without any translation, right? We don't translate this into another language like Java or Oracle PLSQL or something like that. And so that makes it easier to manage, debug, and use. And so it's more work for the project, of course, but it's less trivial to implement, but it's worth it for the developer. And so we made this engine pluggable, but it's an engine that translates this metadata into work, actually. So it gives a predictable outcome. It's version control friendly because we can just version control the metadata, and it's platform independent. So then, okay, so we describe tasks, we don't program them. That's another way of saying that, right? And the description of the task transforms actions and connections. They call this the metadata. And the metadata itself can be entered using a GUI, like you just saw, but it also can come from other data sources with something we call ETL metadata injection, or you can use our programming API SDK if you want to generate this metadata. And then when it comes time to say, okay, now we want to execute this, you can execute this in the Hop user interface, of course. This is what people do when they want to test this, test what they're doing, or just run the one-off. But you can also use the scripts like I showed you earlier. You can run this on a remote server. You can embed this in your own Java code or call it a web service. And, you can also run this inside Apache Spark, Flink, or Google Cloud Platform data flow clusters in your scheduler using Jenkins, Apache Airflow, in a Docker container, in Kubernetes. It's become like a very easy way to just say, I can execute this metadata in any location where I want without regard for what the type of platform it is. It's always available. Okay. An example of that is the pipeline I just showed you, where we define a transform to read a text file basically from a Google storage location, and we write another set of files out to another location, and we filter out the records from California. I just had this run earlier. This is 1 million test records, and it spits out 17,000. And this was executed not with a local engine, but with a data flow engine, Google Cloud Platform Data Flow. And it has a bunch of options like what kind of worker machine do I use, and what in which region, what the project ID is. And what Google Cloud Platform Data Flow does, it starts its own cluster on Kubernetes, on the Kubernetes infrastructure at Google. And then it will start workers, and it will execute the pipeline I just described here. And that translates into this basically. This is the graphical user interface of data flow, where you can actually see how this is going. This is a very small engine. It's also very cheap, but you can see some basic metrics. You can see what the execution environment is and stuff like that. And we actually use this to run integration tests every night for this platform. But similar, we can do this for Spark and Apache Flink. And we can also do this with our own runtime engine. You don't need these platforms. Okay. Yeah. Let's continue a little bit further. Now, the guiding principles is we want to make data orchestration better, right? And so not just so like you see like an easy, simple name, an easy, simple website, the setup, the download, the build. It should all be like easy, and you should have an easy time doing that. And we want to be fast as well. You'll see that it's Apache Hop, the GUI, the tools, they start up pretty fast, and they support the latest technology in terms of scalability and performance. And transparency is key. Before, during, and after execution, we have really cool technology like the ability to execute one pipeline for every other pipeline that you run, which does the logging. And so you can log straight to S3 buckets, or put the logging in some folder or in a database or in a graph, wherever you want, right? That's the sort of thing that helps transparency. In general, it helps that Apache Hop fits into your organizational infrastructure and architecture, not the other way around. And transparency is just one of these things. Like, okay, if you already have a logging server, we want to play nice with that. Predictable, as the next presentation will handle. Predictability is really key to lockdown investments. So unit and integration testings are key. Integration testing is key. Innovative, like I said, the latest technology. We try to keep up with this. And the last item is really key for us. We want to support the best practices that you want to use, like integrated version control support in the Explorer, in the Hop GUI, for example, the ability to test, continuous integration, pipeline, project and lifecycle management, search, all these kind of things are near and dear to our heart. Like I said, we run with an Apache public license, which makes it very business friendly, I'd say. It makes it very easy for you to just take the project and use in your own work. You can even make derivative work from this, based on this. You can embed Apache Hop into other software without any problem. And so we have a very modular architecture which can still scale back to almost nothing. And this is obviously very important for smaller platforms, edge computing. Imagine a small Raspberry Pi-like computer that sends out, I don't know, water flow or humidity, temperature to a remote service somewhere. You could actually use Apache Hop for that sort of thing by simply saying, I want to remove everything that's not interesting to me in that small environment. And then you end up with something like 30, 40 megabytes, which starts fast and consumes next to no memory. And again, I said support for Spark, Flink, and GCP through Beam. Apache Beam is an important project to us. And version control documentation are also really key for us to make sure that we can improve the documentation along with the source code. And we actually create tickets, Jira cases all the time for documentation improvements. And yeah. For the GUI, like I just said, pluggable GUI features, scalable interface for high dots per inch displays, large displays with very 8K screens that are coming about, but especially also for visually impaired people. If you increase the font on your desktop, Hop will automatically scale to match that. So all the icons and everything will scale alongside with that, making it easier for people with bad eyesight, for example. And the perspectives are getting a more prominent place, I guess, in this in the latest versions, especially. And this is not the end. We will continue to improve the GUI, but yeah, this is important. There's more than just a drag and drop interface for data orchestration. You also have metadata search. These are important tasks that you want to do. And we started to design this new Hop user interface from the ground up also for web browsers and mobile users. And so most operations, I think all of them, are by default accessible through single click, which is a single finger from a user. And like I said, the four platforms that we support. And the idea is that all GUI configuration options have a command line variant. So let me give you an example of this. I think I still have a little bit of time because it's quite interesting. So so for example, you would have a key file option here for Google Cloud configuration. This is for the service account, or for Azure, you know, some features. So if you go to Hop Conf, and I guess let's take Azure, you will find a bunch of options with which you can just configure this. And it looks silly, but this is actually quite cool because the Azure plugin itself is a plugin. So this means that the Hop configuration tool and the GUI both are accepting these plugins as having configuration options for command line and for the user interface. So we're very happy with that architecture where everything can be done through HopConf, and this is important for automatic configuration of virtual machines, especially Docker containers where you want to configure stuff. So let's just get back to it. So all the GUI configuration options have a command line variant. That sounds simple, but it was actually quite complicated to do. Whereas in Kettle, you might have like Kettle properties files and a little bit of file spamming all over the place. We have a single central configuration file in JSON, which is easier to read. And that drives the whole configuration for a particular server or workstation. And this makes easy work of project and lifecycle management environment configuration. Lifecycle management is basically I have a project. The samples project is located in a certain folder, and I can configure this environment with a config file, and I can put my environment variable pertaining to that environment in this file. And if I want to put this in production now later on, all I need to do is make a configuration file for the production environment, or modify the file for the production environment to make this work, right? Or I need to create one for a Docker container for continuous integration. And so this separation of the project from where it will be executed in what environment, in what lifecycle environment, is what we call the lifecycle management features. And it's possible to not just have configuration and metadata, but we can inherit it from other projects. So there are scenarios where you have one, let's say, a set of metadata and then 20 child projects that all inherit from that. So those are the sorts of things that are possible already. We have a standard Docker container, which makes it very easy to have zero installation scenarios where you don't have to install the Apache Hop software on a server. You can just use a Docker container to execute stuff. It doesn't really take a lot longer to execute, maybe half a second. And we have a stateless server supporting multi-tenancy. So the Hop server will accept work from multiple people running work on the same server without them knowing from each other. And of course, this whole project setup around a single folder with all the metadata in that folder is very version control friendly, we call it. All right, to wrap it up, I want to talk a little bit about the roadmap, right? So we are here. The next version that we're working on is 2.1. We're thinking about improving the experience for previewing, monitoring, logging, packaging improvements, especially around Apache Beam, an open marketplace, pluggable fields expression. There's a whole bunch of things that we want to work on. Most importantly, we want to hear from you what your needs are. We know, for example, that we want to put authentication and Kerberos and other things on the roadmap as well. Let us know your requirements. Let us know what you're working on. We were very interested in that information. And obviously, let me just throw this in that we are partnering with it-novum, Lima Data, to provide support, training, certification. So that is available for you. And I think now it's time to hand it over to Bart. I hope I didn't take too much of your time, Bart. I think it will be fine, right? And thank you for your time.
All right, let me share my screen. Right. After the technical architecture introduction about Hop, let's have a quick look at what it means to be an Apache project and what it means, even more importantly, to have a community around Apache Hop. Most of you probably have heard of the Apache Software Foundation. The Software Foundation started a little over 20 years ago with a single project, the Apache web server. And well, they needed a non-profit foundation for their intellectual property. And over the course of 20 years, that has grown to 350 active projects, a little over 350. 30 plus projects that are incubating, that are in the process of becoming an Apache project. And they have a federal approach to management. So projects have a lot of autonomy. They need to play within the rules, so to speak, that are set by the foundation. But each project operates on its own. And the growth of the foundation is visible in that chart here. That is not very up to date. There are more projects these days, but the Apache Software Foundation basically is a very strong brand for open source. The 350 projects in the foundation work along each other, but also with each other. And this is, again, this doesn't contain all of the projects available, but as we see with Apache Hop, about 6 months after graduation, we have an increasing interaction with other Apache projects. So the being part of the Apache Software Foundation makes Apache Hop stronger and makes other projects stronger by working together. The foundation and projects have a couple of guiding principles. Openness, of course, as open source. The 350 projects donate a massive amount of code functionality as open source for the public good. Innovation, Matt already mentioned that Hop wants to be innovative. That is true for all of the Apache projects. The Projects tend to be collaborative or have to be collaborative, work together on consensus, make consensus-based decisions. All of the discussions happen on mailing lists out in the open. All of the decisions are made through votes. So it's a very democratic process. The Apache license is open and pragmatic. Matt already mentioned that the Apache license is very permissive. You can, do whatever you want. It's not like other licenses. There's no viral aspect there. And the desire is to create high quality software. And that is what we have in mind with Hop as well. And one of the most important aspects is that the Apache Software Foundation in general and Hop specifically is community-based. Hop is created by a community for a community, and we increasingly see that a growing community creates more interaction, gets more input, has more testers, and leads to richer and higher quality software. So the community is almost a self-fulfilling prophecy. More community builds better software, creates more community, builds better software. A quick word on the history. Hop was started as a Project Hop at the time in late 2019. After about a year of work and development, Hop entered the incubator. And the incubator at the Apache Software Foundation is a process where projects are guided to learn to work the Apache way. So the project team needs to get used to using the mailing list, setting the Apache infrastructure up, learning to go through the voting process. Not unimportantly, the team needs to build at least one release. We built 4 over the course of our incubation process as a community. And even more important than the code, than the project, is to grow the community. And Hop has been very active in attracting a community. We had, as a Kettle PBI fork, we took over some of the Kettle community, but a lot of people came from external, came from our new community members. A lot of people came through Apache Beam, came through other channels, and we have a very diverse community in terms of interests, in terms of geographies, languages. So that's it's an important aspect, and it's very helpful for Hop as a project as well. And then late last year, just before Christmas, Hop graduated as a top-level project. And at that point, the graduation process means that you successfully, as a project, you successfully went through the 3 points that the Software Foundation considers the project to be mature. And at the time of graduation, the Apache Software Foundation takes ownership of the software, of the source code. So Hop now is the Hop code documentation, which is part of the code, is now in the public domain and is guaranteed to be owned by the community, basically. So community means that the development, the discussions, the roadmap are all community driven. There is no single company that drives the software. We have a quickly growing community in social media channels, discussion group, user groups. The community is diversifying and growing in numbers. And very importantly, we set the bar as high as possible for Hop as a project, as a technology. But as far as contributions go and community involvement, we set the bar really low. We welcome a lot of input as contributions. It's not just code, bug tickets, suggestions, documentation, translations, ideas, discussions. All of those are considered contributions, and we appreciate every form of input, every form of communication as contributions. In general, we consider no bug too small or too big to fix. Same for improvements. Even the smallest improvement helps to make Hop better and is very warmly welcome. And just a couple of an overview of the growth of the community. These are just three of the social media channels. So we have the blue line is our Mattermost chat, so a bit like Slack, where we have very active discussions, and then LinkedIn, Twitter, all of those are growing very quickly. And the channels over here are where we invite you to join. Start following Hop on Twitter, LinkedIn, YouTube. We have actually a meetup later today, this evening, about Hop and Debezium. And we invite you to follow Hop, to join the chat, to become part of the community, basically. So that's Hop and community in a nutshell. And I'll keep it to this, then we have some minutes left for Q&A if there are any questions. Thanks.
Matt, Bart, thank you for the very interesting presentation. It's always really great to see, the innovation on the features and the progress on the software. Mm-hmm. And it's really interesting to see, how the community works and how it grows. And I think that's great to see for the people here in the event. So if there are any questions, so please use the chat function. Meanwhile, so we will answer them right now. So meanwhile, I have a couple of questions that I would like to discuss with you. So you mentioned, the history of Hop on the one hand side, the progress of getting a top-level project. Can you please explain a little bit more on the maturity of Apache Hop as a software product? So I think this is something that is really interesting to understand a little bit more deeply.
Yeah, it's when we show Apache Hop, and I was at the Neo4j conference here in Austin. When I show it, people are amazed at, like, okay, so hundreds and hundreds of plugins and a whole suite, and it's like, that's a lot, right? How did you do that in a year? Well, it's actually, we built on, I started Kettle in 2001, so that's 21 years of software development, and especially software development by a lot of people that all came together. So that leads to a high maturity. But what we also started doing is nightly integration testing. This is really, really important for us to ensure that version 1.2 of Apache Hop works in the same way as version 2 and ongoing. So we protect, we use our own tools, the unit testing and integration testing for our own project to make sure that all the transforms act in the same way after a bug fix, for example, right? So we require our developers, our pull requests to add integration tests, which is a simple pipeline and a workflow, a little bit of, it's not a lot, but over the time we accumulated hundreds now. It takes 2 hours to run all the tests every night. So it's a big collection, and we use the Docker infrastructure to do that. So we have a Docker container for Hop and one for Postgres, one for Hop and one for Neo4j, MongoDB, Cassandra, a whole list of technologies that we then test every night to see if everything works. And that has helped stability tremendously. We know immediately if something goes wrong. It's no longer a guess whether or not something is okay, because at some point you cannot test it manually anymore. So yeah, that's to both a history, 21 years of software, but also the things that we're doing now actively to ensure stability and maturity, right? Mm-hmm. And we encourage our users to do the same, because it shouldn't be a guess whether or not your software runs on a new version of, let's say, Postgres that you upgrade, or Oracle, or whatever technology you move to a new Linux server. You should be able to test that, whether or not your whole solution works. So why not, use your own unit test? And I'm happy to see that your colleague will talk about this. It's near and dear to my heart. It shouldn't be a guess. You should know up front. You should be able to test it, right? Yeah. Sorry for the longer answer.
Okay, great, perfect. Yeah, we will see unit testing in a couple of minutes.
Yeah.
We have more questions from the audience. I will read the first one. We have seen the metadata, which is stored in JSON. One part of this metadata are secrets, for example, passwords. What is the proposed handling of secrets so that they are not stored in the config JSON, being stored in version control?
Yeah, that's a great question. So obviously, we encourage people to not store passwords in the pipelines or workflows themselves. We encourage you to store them in the environment configuration file, which we would typically not check into. Version control is a big word, but we would not check it in with the rest of the project. A lot of companies, they store these secrets, these files, in a separate repository where you would keep everything separate. A second thing that we did in the project is offered standard support for asynchronous encryption, so AES 256 password encryption, which would offer further protection for accidental password leaking, right?
Yeah. And additionally, well, there's some work to do. We may build that into the platform at some point, but you can already take keys, passwords from a vault and pass those to your configuration files. It's not part of the platform yet, but that's an external option that you can apply to make it even more flexible.
Okay, great. So next question is, maybe an example for a new technology. Is there, or do you have plans for a Snowflake bulk loader for Hop?
So the short answer is that we would love to work with you on that. It all starts by people creating a ticket in the Jira system. What we'd like to say is no ticket, no issue, right? No ticket, there's no plan if there's no request from the community or from anybody for that. The second thing is that we would like to work with you on this, because we don't all have large accounts on all the technologies. But yeah, we would love to add support for Snowflake bulk loaders, as like we did for other platforms, right? Yeah.
Okay, perfekt. Frau Krohmann, Sie haben die Hand gehoben. Wenn Sie eine Frage haben, dann gerne über den Chat stellen. Meanwhile, I will have the next question. So maybe again a question also targeting at the why for Apache Hop. So where do you see the advantages in comparison to Kettle? So the question is, why did you start developing a project like Apache Hop?
Yeah, again, we've seen the landscape evolve a little bit, and at some point we wanted to do more for the individual data integration user, both in terms of support for best practices, which are now like sort of like the unique selling propositions of Apache Hop, unit testing, lifecycle management, all the things that I mentioned earlier, which are really like fundamentally supporting the project for the standards best development practices. We shouldn't ignore them, right? We shouldn't just skirt around them and say, well, we're moving into automatically generated documentation, but also things like fast startup, right? We removed Carafe, which was like dragging us down. We really wanted to support Apache Spark, Flink, Dataflow through Beam, which was also a problem getting that to run on Kettle. So those were all like, it's not just one reason, but like a whole bunch of them. The documentation was a little bit all over the place in the Kettle projects, especially speaking about the open source version then, right? So yeah, all of those were, it's not just one reason, obviously, it's like a whole list. Yeah.
Okay, great. So next question is, why are there two different Kafka consume-produce transforms, one for Beam and one native? What is the preferred use of them?
So both are different. So Beam and the regular local engine have different execution models. In Beam, every record is serialized and basically monitored throughout the whole execution of the pipeline, making it, I guess, topologically a little bit easier to know that a record that came from Kafka is persisted somewhere and safe to be acknowledged on the queue. For the regular local pipeline, which is a simple optimistic, if it fails kind of deal, we had to make sure that we process the records in small batches and make sure that they're safe before we grab new records. So yeah, use Beam, the Beam Kafka consumer in the Beam context on Spark, Flink, and Dataflow. And the other one, if you run with a local engine. It's not something we could easily fix because it's a difference in the execution topology of the engines. Yeah, I guess the same will happen once we have Kinesis, and there's also the Azure event hubs fall in that category. Obviously, Kafka is the most popular one, but yeah, it will be tricky to unify those things. But yeah, functionally they work just the same, right? Okay.
Okay, great. So we have one last question. We run hop run shell to execute pipelines locally. Can I use hop run shell inside a container as well, triggered by a cron job? And is this best practice? We have currently stored all our pipelines in a single Git repo and plan to execute each individual via the cron jobs. Any suggestions?
Yeah, great questions. Fantastic that you're doing that. So Stefan, what we found was that it depends, right? I had one project where people actually put did a Git pull and put that metadata inside the Docker container. So they had their own customized Docker container. And such a simple act would give you the execution runtime, hop, and the metadata alongside each other. And since Docker version controls basically the images, you can go back in time to see what got executed. In your case, there's no need. If you just want to run a Docker container, that's the Docker container Apache/hop. And there are two variants of that, the short-lived and the long-lived container. Typically what we do for the short-lived container, which is a pipeline that you want to execute, you run the Docker container, set a few environment variable, and think it's hop file name, basically, some file name. It's documented on the web. And it will just run your pipeline without having to install anything, straight from the Docker container. There's other ways that you can say, I'm gonna mount the project folder inside the Docker container with -v in the Docker command. Yeah, so yeah.
Okay.
Yeah, and I can maybe answer the last one as well. Yeah. So the web GUI, we build it's just a war file. It's a file called hub.war, and you can throw it in Tomcat. It's not just for Docker, right? It's you can run it in any web container, basically.
There are instructions to build your own Tomcat configuration for Hop Web on the Hop website. I'll paste the link in a second.
Great questions. Thank you very much.
Yeah. Thank you again, Matt and Bart, for joining us. It's always a pleasure having you at our events. And yeah, have a good day or have a good night, Matt. Talk to you soon. Thank you.
Thank you. Bye.
Bye-bye.
Bye.